Next, we're looking at bond value as it evolves over time. We're going to notice kind of a logical pattern here. The first thing that we remember, again, because the bond's a contract, is at the day of maturity, regardless of what happened to the price over the entire life of the bond, on that day, the full amount of face amount is due, no more, no less. Again, the bond's a contract. If the bond were a premium bond, in other words, with a price higher than face, that premium is going to shrink over time as it gets closer and closer to maturity, because bondholders aren't going to pay a premium for something that's going to be worth less in the future. You can think of it as the day before the maturity, there's a tiny, tiny premium because you get a little bit of extra yield for that day. But on the day of the maturity, it drops exactly to the face amount. And that same dynamic occurs if it's at a discount. So if the yield required is higher, and therefore the investors require to buy it for a cheaper price than the face, that discount will also shrink, because on the day of the maturity, you're going to get $1,000 anyway. So that discount drops essentially to zero, and the face amount is paid. And if it's a par value, well, of course, it doesn't move at all, right? There's a picture we could look at that shows how this might look. This is, again, theoretical, because we don't know exactly what happens in the marketplace. But this top line here represents what happens if it were a premium bond. That premium bond is going to drop in value, and at the end of its life, namely out here, it goes exactly to par. Same thing if it's a discount bond. If it's a discount bond, it's issued below par value. But again, at the date of maturity, it has to exactly equal the face amount. And if it were issued at par, not very exciting, it just stays at that number all the way through to maturity. That shows that at maturity, the values converge, and it converges to the face value, because that's what you're going to pay by contract. So the next way to look at this is, rather than we look at the price, let's look at the yield to maturity. What is this percentage interest rate that is required by the marketplace? This is also called sometimes the promised yield, right? This is a yield if every payment occurs as scheduled. This is the yield that the holder will get. One huge assumption is that there is no default. There is a risk of default on all bonds, hopefully not U.S. T-bills, but all corporate bonds has a risk. It could be a small risk or it could be a large risk, but there is a risk of default. So what happens with an example is here below, and we have a 10-year bond, 9% coupon, $1,000 par, selling for $887, right? So these, again, are the parameters of the bond, and here's a picture of the cash flows. Is that we're paying out $887 now, so that's the price. The cash flows are going to be equal to the coupon rate of 9% times the par value of 1,000, so it's 90 for each period. And when we get way out there to year 10, we'll also get the $1,000, right? So that's, we know that from looking at it from a pricing standpoint. But remember, in the pricing standpoint, we knew the interest rate. Here we do not know the interest rate. So we're solving for the other side. So rather than solve for a price, we're going to solve for the interest rate that makes that entire system of cash flows work. And luckily for us, there's a function for that. Similar to, there's an app for that on a smartphone. There's a function for that in Excel. So let's look at that function. It's called the yield to maturity problem, and I just replicated this scenario here. The function is right here. It's an Excel function called rate. Value of the bond equals rate with the parameters of number of periods, amount of each payment, the present value, which is the price, future value, which would be the last payment, the type, which just means is it end of period or beginning, and we could just accept the default. The default is end, and that's what we're doing. And so let's put in the numbers. What are the number of periods? It's an annual coupon, so the number of periods is 10. 10 years, 10 payments. Next is, what is the annual coupon payment? We know that equals the coupon rate, 0.09, times the face amount, 1,000. So each year we'll get $90. The present value is given at 887. The way we're going to do this is, remember I talked about the analogy of your pocketbook and you're paying money out or getting money in. Notice that if you're the buyer of the bond, you're getting the 90 each year, but this 887, you're not getting 887, you're giving 887. So that's a negative number. This is critically important to know that price is going out of your pocket, payments are going into your pocket, so the signs are correct. And the future value is you're going to get $1,000, and that is a big positive number. So now we're ready to go. We can go equals rate and open parens, and we get the parameters, and we just point. Number of periods 10, the payment 90, the PV negative 887, the FV is the face, close parens, and the yield is 11%. So this means that if we were able to buy this bond for 887, the yield that we would accomplish is 11%, and this is the yield to maturity. And the reason for the term yield to maturity is that's the yield to the investor if the investor held on to it all the way till the end of the life of the bond, right? Yield to maturity. Okay, so that's the first example, kind of a base case on yield to maturity.